Okay, thank you very much, Dr. Mohsen, for the introduction. And okay, I'm a bit nervous now because the thing is that, like Mohsen said, so I did my PhD in UNSW, and also uh, now I'm a postdoc there or two. And then I basically I've been spending in the I don't know the last 4 or 5 years, like working in a military barracks, and then like so I did not see, and I do not see, this many people because mostly like like teaching just like a cadets, and then like like don't really have the civilian students, just like few. So like it's very refreshing to see a lot of because I am also a civilian, so then to see a lot of familiar face, like, oh, that's just like me. So rather than the cadets that use uniforms. So yeah, and thank you very much for having me, especially like for uh people that attending, because like now we have sudden rain, and then like I thought that it's going to be fewer than this, but then like a lot of people show up. So yeah, I really appreciate that. So the thing is that I'm actually here by accident because Dr. Andres invited me here, and then like I think he thought that I am in Sydney campus, but then it turns out I am in Canberra. So then it's a bit accidental to see you guys here, but yeah, I hope that it's not going to be a disappointing presentation for you guys. And that's enough introduction, I think. And so the thing is that today I will talk about my research work that I've been working on in the last several years. And basically it's about drone sharing in logistics, which is actually like an extension of one of my chapters in my dissertation. So it's actually like, like a small extension of that. And then that I tried to make it as a, like a new research stream in my portfolio. And then like, I think it might be interesting for some of you guys, hopefully. And yeah, some of the background, like I mentioned before. So I did my PhD in UNSW, but before that, I was in Indonesia for my bachelor and master. So I'm Indonesian. And then I also spent a year in Taiwan for a year there for my master before, yeah, moving here for my PhD. I was a lecturer for a while in Universitas Gadjah Mada, which is like one of the most prestigious universities in Indonesia. And then I also, actively contributing in several society related to my research area. And then most of my research, they are actually in the intersection of transportation, which is, I think, quite related to the topic of this research group. And then mostly I work in what I call as a good logistics, because like I try to see logistics from how we can minimize the negative externalities, and also try to like utilize logistic in a good things, which I will mention later on. And then I have been working on with a lot of evolutionary algorithms, just because like I'm trapped in the evolutionary optimization group by my supervisor. So I didn't really have much interest in that area actually, but then like like once you get in, then you cannot get out. So yeah, I'm actually trapped there in the evolutionary algorithms. But yeah, it is what it is. And yeah, if you have any question, or maybe like like if you think that our research is going to be aligned well with me, so you can just contact me through that emails and stuff. Okay, so today I would like to discuss with you guys. The first thing is going to be about the idea of drone sharing, or I think some paper now called them as a drone as a service, including my recent publication, or DAAS. And then we'll discuss about how we try to integrate drone as a service or drone sharing concept into logistics in our recent work, and how we develop a routing problem from there, and then try to solve them with the evolutionary algorithm. And then we will try to discuss about several research directions that we have from there. Either that, like the one that I'm working on now, or maybe like the one that probably some people, not me, will work on. So hopefully that, especially for the PhD students, I think some of the audience, you guys are PhD students, right? Oh, most of them. Okay. Oh, okay. Yeah, I mean, especially for the students, I think hopefully that can be something that beneficial for you guys, maybe either for the short term for your dissertation or maybe for the long term. We'll see about it. Okay, so first thing first, about the introduction. So I'm not really sure if you guys here, some of you, especially the PhD students and the master students, I'm not really sure how familiar you are with the current state of the art of the literatures in the logistics, but adopting drones, or sometimes people call it as unmanned aerial vehicles, it has been a hot topic in logistics. I think it's been about 10 years since the paper from Colorado, I think, about the flying sidekick traveling salesman problem. So the thing is that how the topic is about how we can utilize drones as an alternative to aid or to to assist how assist the performance of logistic system. So one of the most important thing in that topic is about the collaboration between drones and trucks, because before that actually there was some papers that consider how about if we use drones to uh, delivering maybe parcels or maybe like food deliveries. But the thing is that drones, they're always be limited by several mechanical constraints, like like the payload issues and then the battery also. So some researchers, they tried or they came up with the idea of what if we use drones, like just as a sidekick. So the idea is that like the drones will be attached to the truck or electric vehicles, for example, and then we will use that just basically as it needed. So not like not that we will try deliver all the stuff with the drones, but then like we just need to, okay, maybe that particular customers, they can be delivered with drone, but some of them maybe we just use the truck. And then from the computational side, it actually becomes very interesting. Can we actually move this out? Oops, sorry. So from the computational side, it becomes quite interesting because if you are familiar with the vehicle routing problems or like traveling salesman problem, usually they maintain just one vehicle, or maybe like one type of vehicles, for example, like several trucks, and then they like they operate independently. So you don't really see the connection or collaboration between them. But then in this case, like we have the thing that we call as synchronization. Why we call it as a synchronization? Because when we have drone and trucks, for example, at the same time, so that means that the movement of drones and trucks, sorry, that should be movement of trucks and drones, right? They are interconnected to each other. For example, like you can, like when the operator of trucks, they fly the drones, maybe they need to wait for the drones to come back to them first, and then continue to the next node, for example, like that. And then there will be like a time or temporal synchronization as well because of that, because like one vehicle might need to wait for the other one, for example. And then also there will be a lot synchronization, because that means that like when the tour starts, the trucks, they need to bring the payload of drones as well, because like the payload, the drones, for example, like drones needs to the drone needs to deliver to the civil engineering building from here, for example. So that means that the trucks, like the packets, they must be in the truck, not like like suddenly appear, right? So there will be like some kind of synchronization that from the computational side that makes the problem becomes more difficult. And in the literature, there are actually several ideas of how we can try to use drones into the logistic system. For example, here the first one in the left-hand side, that's one of the classic model from the literature. This is the seminal literature in this topic from Murray and Chu from the Colorado State University. So the thing is that this is the truck, like the solid ones, the solid lines, they are truck arcs, and then the green circle, they are like the how is it, like the limitation of area of drones, because they have a limited battery, so they can only operate around this green circle. And then basically the drones, they can be used to visit customer nodes that falls into this green circle. And then for the other ones, we can use trucks, for example. That's like one of the popular model in the literature. And then there are several ideas as well, like the middle one. We can see that here the trucks move to one area, this blue area, or maybe like, yeah, this one is going to be easier to see. So for example, like the trucks come to this top blue area, and then the operator will operate drones from there. So several drones, for example, like from this blue to C7, and then to C9, then come back again, and then one to the C8, back again, one to C10, back again. And that's one way of operate that. And then some idea, they also consider like the simultaneous drone system like this. So, like just like the one that I mentioned. So we have one truck, one drone for it. And then basically when the truck move, we can also separately use drone to deliver to another place, or maybe some places, several places. So basically in the literature in the last 10 years, there has been a lot of discussion on this issue, and a lot of people, they have tried to introduce new models. Some of them, like they don't really make sense, but some of them, they are really making sense. So like it's just how we work in research, right? And so in my recent project, which actually was based on my dissertation, we tried to challenge the assumption that the assumptions in the drone-aided routing problem, because the majority of research in this area has considered these assumptions, with actually, like to be fair, like my previous paper before I did my PhD, I also did the same mistake. So like I tried to looking back at my past mistake and then see like, okay, how can I improve that? So basically, a lot of literature in this area, they consider the following assumption, that the drones, they are already available. So for example, like, like when, if you're familiar again with the vehicle routing problem, for example, usually the basic assumption is that we have like several number of vehicles. So that's, like it's you can imagine that we are somebody that works in like, some company like maybe DSL or carrier logistics, and then at the start of the project, we already have, like let's say like 10, 20, 25, 30 different trucks or vans or maybe electric vans, things like that. But then in drone-aided routing problem, a lot of the literature, they always assume that, the drones, they are already there. So we already have trucks that are attached with drones that's already available there. And then some of them, they only consider travel costs and neglects, like the ownership cost of drones, because, like when you have drones, they are actually not as cheap as they are, right? That people thought, right? Some of them, they can be, as expensive as the truck itself. And that's something that usually neglected in the literature. And most of them, they also just consider the performance, So they basically just evaluate the improvement of the performance. So most of them, they just see that, okay, we have drones now, and then see how differ the system than when we didn't have drones. We thought, seeing how feasible it is actually, the system. So we tried to challenging the assumption in this project to see, are drones really, really feasible for this, like to be operated in the commercial operations? And the bad news is that when we did the evaluations in commercial operations, most of the time, not most of the time, but that I can say that drones might not be feasible for commercial operations, because like we actually have to consider the fixed cost as well, and then like a lot of literature in drone aided routing problems, they actually just consider this kind of operation. So a lot of people, they call this as a sortie that, like, so we have, for example, this is A node, and then this is B, this is C, this is C. So that means that, like the operator, they will fly the drone from here, and then the drone will serve B, and then after that, the drone will move to C, and then it is retrieved back in C. So the assumption that is just that, like the drones, they can only bring one packet per flight. And that's actually a very, very, very realistic assumption. It's not a bad assumption at all, because that means that, like when you consider the technology now and the regulation that we have, especially in Australia, like, when you bring large packets with drone, for example, like I'm talking about the extreme stuff, but then like we just cannot bring, like refrigerator with drones, right? Or television. So for example, like, somebody order television, there is no chance that we will, deliver them with drones, right? We will bring it with with the trucks, right? But then that's a different issue when we have, for example, like, people just order, like shoes or maybe like food, for example. Okay, maybe we can try to use drones. But then again, like, when you have fridge, there's nothing, no way that you can use drones for that. So this assumption is actually, a good assumption. But at the same time, the thing is that when you limit the way drones can be utilized, that means that, drones, their utilization level, they are actually very low, because that means, for example, like consider when you have 100 customer, for example, and then when you can fly drones just to one location, that means that, and then like you need to have one or two, for example, one location to fly drones. That means that, at maximum, you can only have like 25 until 50% of customers that you can serve with drones. So that's really limits the number of the utilization of drones. And that becomes an issue when you consider the, like the cost that you have to pay for having drones, like for maintenance, the electricity, and all the stuff. That becomes an issue. So the thing is that in this project, we try to ask ourselves and to see what kind of new models that we can, try to came up with to solve this kind of issue. And the idea that we had, that we came up with, is drone sharing, that we call as drone sharing or drone as a service. So the thing is that in this, project is that what if we, just rent drones for the third party rather than we own that? So basically, it's a bit, it's a bit evil things to say, but then it's like, let them eat the cost, ownership costs. Let them eat the depreciation. Let them eat the fixed costs. And yeah, that's the idea that we came up with. So this idea was based on my experience, actually, like personal experience, because I grew up in Indonesia and we see a lot of people that, like use ride sharing business a lot. Like I think here also, like a lot of people, like you order different platform and then they, deliver your food with electric bikes here, for example. And that kind of service is actually really, really, really big in Southeast Asia. And then, yeah, and I'm not going to say that it's actually like, totally good business, because there will be a lot, there has been a lot of issue that came from this kind of business model, but then like, yeah, that's the idea. And then in this project, we tried to expand the idea of drone stations that was discussed in this paper in IEEE Transactions in 2019. That so basically this paper came up with the idea of what if the company setting up a drone station nearby the CBD, because the thing is that like most of the time the company, like the logistic companies, most of the time they only have the warehouse like outside of the CBD, because like setting up a large warehouse in the city, that's going to be very costly. So they came up with the idea that, okay, what if the warehouse like outside of CBD, but then now what if we just have drone stations nearby the CBD, so we can try to deliver some stuff, some packets around the CBD area with drones, and then for the other ones, yeah, we basically can just we can use trucks from there. And then, yeah, we basically try to expand this idea into the idea of having a third-party drone stations. So what if, like not the company or company that has the drone stations, but what if there are, a sparse of drone stations, sorry, third-party drone stations that they are available to be called on demand, around the CBD or maybe like a crowded area. And that's our idea in this project. And yeah, so this particular material was published in the International Journal of Production Research recently. And this is actually the part one of our research in this topic. And yeah, we basically try to integrate the drone sharing providers into a logistic system that we built in the previous project. So in the previous project in my dissertation, I basically tried to integrate the electric vehicles and drones. And that's why in this article, we tried to integrate a new idea, a novel idea of having drone as a service providers here. And then we try to evaluate the idea from the performance side, which is, again, for to be fair, is not really answering all the assumptions that I mentioned before. But yeah, this is the first part of our project. And then the extension model that consider monetary parameters, they are already, we have separately proposed that, and then now it's under review in a different journal. And like how it works in this idea is that now we have, like for example, here we consider that we have one set of truck and drone or EV and drone. So let's call it as a tandem. So we have a tandem here works from, this is the DO, it's basically the depot, and then these triangles, they are drone stations. And this is the, like the circle. That means that, that's the working area of the drone stations based on the limitation of battery of the drones itself. And then, the yellows, they are the customers. And then, yeah, this one, the green one, they are recharging stations. And this actually, like this, how it works is actually, it's valid for whether, if we only have truck and drone tandems, that's basically the same things. So the way it works is that now we have an idea of what if the truck from the depot, they can just visit, they can just visit the drone sharing providers during their tours. And then basically the goods can be transferred there. So for example, okay, we want to allocate, for example, 5 customers to drone station around this area, or maybe in Redfern, for example. And then, like we visit that station with a truck and then transfer the goods there and then let them work. That's basically how it's done in this model. And then after that, the drone sharing providers, they will deliver the transfer goods in round trips. So, back and forth like this. So from S10, they came to C3 and then go back again, and then to C5 and then go back again. Maybe they have only one drones, maybe they have more than one drones. That's can be the case in this model. If you have any questions, just let me know. And from the computational perspective, again, this problem becomes a very, very difficult problem because it's basically a, like a long generalization of TSP and VRP. And this is actually also a form of location routing problems. So if you're not familiar with that, that's like extension of TSP and VRP. Like if TSP, we only sequence the tour of a single vehicle, and then in VRP we have more than one vehicles, and then in LRP that means that we discuss about we consider the sequence of tours, but at the same time we also need to consider, for example, like if we have several alternative locations of warehouses, so we need to select that as well. For example, okay, we have 10 alternative locations around Sydney CBD, but maybe we don't need to use all of them. So that means we need to select a subset of them, and that becomes an LRP because that means we have to consider the selection of the locations, and also we need to consider the sequencing of the vehicles. And this problem is actually the extension of the LRP, because that means in this problem, we consider the sequence of the truck and drone tandems. And we also need to consider the selection of which drone stations that we need to use. For example, like if in Sydney CBD, let's assume that we have 10 drone stations that we can use. Maybe we don't need to use all of them. Maybe like just one of them, 2 of them, 3 of them. And that's basically becomes another thing that we need to select in our optimization problem. So that means that in our problem, we need to consider the sequence of the tour of the EV and drone. And then we also need to select a subset of drone stations to use. And in this particular problem, we also consider the scheduling of drone visits from the drone station itself. So basically, those characteristics make this problem become more difficult than generic rating problems. And yeah, this is just like a simple illustration of this issue. For example, like consider that we have just truck trip routing problem with trucks. That means that for its combination of or pair of customer or pair or locations, we just only have, for example, like this A, it is B. That means the option is just, okay, should we use truck to go from A to B or not? That's only two selection of options, right? But then if we have drones and then they work as a tandem, that means there is a chance that, okay, maybe we can use truck to go from A to B while drone is attached there. Maybe we can use the drone only, so from A to B. Maybe truck will do, the trip to A to B alone because the drone is flying somewhere else. And then there is a chance that we need to synchronize to the drone and truck because they are working separately. And then we want to, synchronize them again in P, for example, like that. So there will be a lot of different options in this kind of model and the problem. And then, like you can see that, the search space becomes larger and larger if you compare with the basic TSP, for example. So in our project, we tried to come up with a solution method for this kind of problem. And the solution method that we designed, it was based on the evolutionary algorithm. And then we tried to empower that with the local search, basically as a memetic approach, if you are familiar with that. So basically, we use the genetic operators to ruin the population that we have. And then after that, we try to use the local search to, try to search for the local optimum of the search area. And yeah, basically from my experience in the last couple of years, this has been a very, very effective approach in tackling drone-aided routing problem because it has a very, very different search space, like I mentioned. And in the next slide, I try to give an illustration, simple illustration of how it's different. So yeah, this is the idea that we use in the couple of years. Basically, trying to combine the evolution algorithms like GA and then try to having a local search to empower that. If you're familiar with like heuristic solutions, so you know that there are a lot of different frameworks like large neighborhood search, variable neighborhood search, iterative local search. But yeah, it's up to us to design, and this is the thing that we find to be effective in our case. So yeah, this is one of the illustration of how this kind of problem can be tackled with the evolutionary algorithm. Because, for example, consider the first case here. So when we have a VRP, for example, vehicle routing problem, we only have several vehicles with the same type, for example, trucks or electric vehicles. Usually in the literature or when we build the algorithms, we will try to, like define them as one string like this. So we use the 0, for example, here. We use 0 to, cut off the different tours. So this is the first tour for the first vehicle. This is the second tour for the second vehicle. This is the tour for the third vehicle. This is how we usually do in VRP or TSP. If it's TSP, yeah, that's basically we just have one string with 0 and 0, at the end of the solution. But then when we have drones and trucks like this, they work as a tandem. Some literatures, some of them, they use a combination of two strings like this. So the top one is basically the same thing like this, but then the other one sometimes binary, sometimes integers. We use them to control how we visit the permutation of nodes for the uppercase. That's how we usually do it. For example, like here, we have 0 to then 4 and then 5 and then 6. And then the sixth one, this index has 1 here in the lower case. And then that means that the number 6 will be visited by drone. Is it the same? Yeah, like this in right-hand side. So this one from the typo 0 and then go to the 4, go to the 5. And then because 6 is 1 here, so that means the drone will fly to the 6. And then because this is 7 and then this is 0, that means they will synchronize in the number 7. This is how we do it in this case. And like I actually did another project, a bit separate project, when we have a multi-visit drones, for example, and then we will use not only binary, but then we also consider another integer of 2. So that means that like 0 means truck, 1 means drones, and then 2 means the truck will visit that node by itself, without the drone. That's how simple idea to use that. And in this project, we try to contribute to, because we have a drone station here. And for example, like if we back again here, like we just have truck and drones here. But then now we have the drone stations. So we try to come up with a new representation for the solution, new solution representation. So we basically add another part here, the third part, to represent the selection of station. So this part, like 9, 9, 10, 10, 9, they are only there for customers that they can be served by drone. Sorry, by drone stations. So for the other, like 1, 8, 7, because they cannot be served by drone stations, maybe because of the payload, maybe because of the battery. We don't put, we don't put another layer here for them. But for these customers that can be served with drone stations, we put another layer. And if it's, for example, if it's 0, that means that the drone station, they are not used in this case. If it's 10, for example, okay, that means that the drone station 10, they will serve that particular number 3. That's our idea. And then I think this too. And then after that, we use a combination again of genetic operators and local search. For example, like here, we use this crossover or the crossover technique to generate the new offspring. And then after that, for each offspring, we try to find the local optimum for them with a set of searching operators. And then we try to implement this concept in a numerical experiments with a data set that we have from the previous project. And then basically our objective is going to be, validating the effectiveness of our proposed approach, and also try to evaluate how the incorporation of drone sharing or drone as a service providers will affect the system. And for the first purpose, we try to use 2 baseline algorithms from the recent literature. This is the variable neighborhood search and multi-start iterator ELS, iterator local search. And very straightforward. In the first experiment, we compare the performance of our memtic algorithm to the VNS and MSELS, and we found that it consistently returns better performance than the baseline algorithms. So we are confident to, try to propose that as a solver. And after that, we try to, again, evaluate the impact of employing the drone as a service providers into this case. And very straightforward, the first one, when we have new logistic solutions like this, we found out that it offers us with a faster delivery, which is good, and it also lowers the utilization rate of the ground vehicles itself, utilization rate of the trucks. So it's lowered, which is, again, it's very good because that means that we can try to reduce, the utilization of the ground vehicles. That means it can mean we reduce the road congestion as well. But then at the same time, that also means that we, like the drone station, the trucks, the utilization trucks of the utilization rate of trucks, they are reduced. Why they are reduced? Because we use more drones from the drone stations. So that means we will need to pay more cost to the drone station providers to use their service. And that means that, like the benefits come at a higher price. And what we also observe in that issue, in this project, is that the first thing is that we try to evaluate what if we have, like in some instances, we put random drone stations into the area, like sparse area, and then like we just put the drone station randomly, and then we basically try to compare that with the strategic DS, strategic drone stations. That means that we use, we put the drone stations in location that they are, for example, like they are in the median, nearby the median of customers, for example. So in the CBD, and then we put one, like several in the CBD, or in this case, the random one. So that means like we put them, like outside of the CBD, and then it turns out that very obvious that, like the drone stations that they are nearby CBD, they will be used more and more rather than, like the random drone station, which means that there is a chance that, when we set up the drone station in the CBD, that means we need to pay, more cost to set it up, right? And then there will be an issue as well of how the system will be operated. For example, like when I'm sure that a lot of you guys are very familiar with the ride sharing service. And then when we use a ride sharing service, usually we will go to platforms, right? We don't, we don't really call them like one by one, like, oh, can you deliver my food? Like you don't really call them, the driver, but you usually use the platform, right? Maybe like Uber, maybe like a Foodpanda, all the stuff. So the issue that we can discuss here is that how this kind of operations will be, like if it's going to a real life, like how it will be operated. Like, will it be, like the company goes to a pool of independent contractors, like, when we have Uber, like we have the Foodpanda, all the stuff, like they are actually a pool of independent contractors, right? Without any security of, job security. Or is it going to be, like a one by one relationship between the company and the drone station providers? For example, like, okay, if we imagine that in Sydney, now we have a drone station company that they have, hey, I have 10 location of drone stations that we can use on demand. So that could be like a one by one relationship, right? And yeah, that's one thing that can be an issue in this point, because, again, when you have a pool of independent contractors like Uber, that means that there will be a lot of issues, like I'm not really sure if it's the case in Australia, but in Indonesia, we have had a lot of demonstration from the side of the rider side, because they feel that, okay, I need to be paid more, or maybe like they want to have more job security, for example. But then like, like from the side of the company, or like Uber, like Foodpanda, they basically just say that, but you are independent contractor, so that that becomes a new issue, uh, in this, like we tried, basically the ride sharing came up as a solution, but that solution, it turns out, like it made a new issue for the people. And then basically we also can talk about, like the general concerns about using drones, because, with drones, we still have a security and privacy issue. For example, like, like people can just fly drones and then like, captures some images from other people's home, which is like very, very, very dangerous thing to do. And I'm pretty sure that in Australia, we are actually quite good in that area, right? Because like, I think for people to operate drones, people here, we need to pay around $49 to, like, to be a drone operators. While in some countries, for example, like in Indonesia, like people can just buy drones and then like basically fly them as hobbies without any kind of, in some area. That's a very, very like very free thing to do. So that can be a one issue. And also, the general concern about drone, another one is the reliability of drones itself. Like if we have rains like this, that means that we cannot really use drones. And then in that case, okay, what we need to do then? For example, like, okay, the goods are already transferred to the drone stations, and then now suddenly raining, what we need to do? And then again, the profitability. So from this project, we actually tried to came up with several new ideas of future research direction by, again, the first thing, the location issue, because that means that, okay, well, how should we decide the location of drone stations? If we're talking about, from the point of view of the drone station companies, like, okay, how should we decide that? Okay, well, should we go just, set the stations in the CBD, for example, and then CBD, that means that it's going to be very, very costly. And then from the computational side, we can also talk about how can we integrate the location decision into the planning horizon. And like the one that I talk about, the disruption issue, for example, like because drones has a very, very low reliability, to be honest. So that means that what if we already transferred the goods to the parcels to the drone stations, and then it's suddenly raining, or maybe like it's suddenly windy, and then what will be the contingency plan? What are the recourse actions that we can propose to that situation? Because when you have, for example, when you have a parcel logistic business, for example, like you order a shoes, and then like that shoes is already in drone station, and it's suddenly raining, and then there is no chance that the company will, I will deliver you another shoes, or maybe like different packets, right? Because that package is supposed to be for you only. So that means we need to have some kind of recourse action to tackle that kind of issue. And then the last thing, we can also trying to evaluate the feasibility of drone as a sharing concept, or drone-aided logistics system in general, because again, we still have so many issues in this area. Like I talked about the first one, like, there is a chance that there will be, if it's going to be like a pool of independent contractors, that means there is a chance that, the people who works on this area will not be like there will be a conflict between, the two sides from the contractors and the company, and then that can be a new issue in this point. Or we can also evaluate whether this concept is actually feasible or not. And personally, from this concept, I actually have tried to expand this, or like based on this, and then like try to came up with new idea of how we can utilize drone-aided routing problems or drone-aided logistic systems in several areas. So my is a bit personal, but then like my current project is actually the first one. We try to come up with idea how we can support motorbike-based urban delivery systems, because that's I don't think in Sydney that we use a lot of motorbikes, but in Southeast Asia we basically use motorbikes as our own primary urban delivery system other than trucks, and then we try to come up with how we can support this kind of delivery system with drone stations. And then in the second project that I'm working on now with my supervisors in UNSW is how we can support the humanitarian logistics systems using drones and or drone stations. And yeah, they are basically the things that we are working on now. And I mean, for especially the PhD students here and the master students, I think you can see how, like from one simple idea and how from challenging the simple assumption of the current state of the art research, how we can drive it to, having different research project with probably different perspective. And yeah, I hope that you guys can learn from that. And that's all. Thank you very much.
So we have time for some questions.
Oh, yeah.
In telematic analysis, how do you solve the local optimization problem?
Oh,
Locally.
okay. Yes, exactly. So let's go back here, because I was actually skipping this part a bit because try to save some time. So in our implementation, because again, yeah, you mentioned that it's I think, sorry, that's a very, very correct way to see it, that this problem becomes very, very complex actually, and the search space is actually very tight. And honestly, when we try, I mean, I not discuss, but I debate about this a lot with my supervisors, because like when you have evolutionary algorithms, what we are trying to utilize is actually how, like when you have evolutionary algorithms, that means you usually start with a bunch of random solutions, and then you try to like exploit those random numbers or random particles to find a good solution. But the thing is that what I found is that when you have a very tight search space like this, usually it's a very, very hard to to find even finding a good, the evolutionary algorithm itself is very difficult. So that's why I came up with two ideas. The first one is I tried to find did not put it here, but then the thing is that we usually put a good solution into the initial population. So like just one good solution. Usually, for example, we can build it from the heuristic. Yeah, for example, like if we have truck drone tandems, for example, we can start from building a TSP solution. And then after that, we can, from the TSP solution, we can expand that into a truck and drone logistic. Yeah, exactly. Yeah. And then like a warming up start. And then after that, when we are talking about the genetic apparatus and local search, the local search actually has a very strong impact to the searching process. For example, in this case, I usually use variable neighborhood decision. So for example, like, we have, for example, here in this case, we have 4 searching operators, like a random swap, and then like, like a simple move, one, for example, like one for the search space of vehicle mode, one for search space of vehicle node, and one for the, drones. Yeah. Exactly. Yeah. And that's usually a very, very effective way to do it. And basically that's a quite easy way to solve it.
So the last slide, you mentioned that motorbikes are used as the so, what are the cases where drones are better as a last mile delivery?
Okay, that's actually, that's actually a question that we are trying to answer in our current project. But like what I found in the from my dissertation was actually that my dissertation actually, like is about drone-aided routing problems. But then I must be honest with you that, like I said before, that I'm actually not 100% sure that drones are actually, feasible to be used, entirely used in last mile like logistic systems, because, like especially when you compare with, with motorbikes, that, motorbikes, they are cheap, and then a lot of people, they are more familiar to, ride motorbikes rather than using drones. And then because they are cheap, that means that, like the transportation cost per distance, they are also very cheap also. And then they are also much, much safer than drones in terms of, like the safety, because, like with drones, there is a chance that, your foot is going to be dropped in the middle of the road. But then like with motorbikes, that's, there is less chance of that happens. So okay, I'm opening my card now. So the thing is that the thing that we are working on now is that we are actually not trying to, replace the motorbikes with drones, but we try to come up with a solution of how drones can be used to support that. For example, like in one of our projects that we are working on now, I hope that we can finish that before somebody here finish it. I also try to work on it, right? But then like in our project, we try to came up, okay, what if let the motorbikes do the main delivery stuff, and then use the drones only as a recourse action. For example, if something happens, during the delivery, the drones can be the plan Z for that. For example, like the drones can came to the restaurant, maybe like if it's accident, so the drones can go to the restaurant and then pick up the food there and then deliver to the customer instead of the riders. That's one thing that we are working on now. But then, like there are actually some ideas in the literature. For example, like a new paper, we are not entirely sure whether it's going to be profitable or not. But then one paper, I think in I maybe forget in which journal, but then that particular paper, they literally tried to come up with the idea of, having a motorbikes and drone that they work in a synchronization basis. So for example, like, the drones can pick up the stuff, the parcel, and then they will be transferred to the motorbikes in a particular location and vice versa. So there are actually a lot of, possibilities to that, to use drones to support the motorbike-based system, but I'm not going to say that they are going to replace that.
Okay, thank you again.
Thank you very much.